Hi guys, so today we're going to learn how to graph exponential functions. Okay, so let's start here by talking about what exponential function is. Okay, so an exponential function is a function that's in this form, f of x, also known as y. Okay, it doesn't always have to be f of x. It could be g of x, h of x, r of x, t of x. It doesn't really matter, right, which letters here in the front. But it really just means y. It's just our output. Equals a times b to the x plus c. Okay. So tomorrow we're going to talk about writing exponential functions, but just something to keep in mind, a is normally our starting point or our starting amount. It isn't always the case, but that's usually what it is. Okay, so a here is usually our starting amount if we're talking about word problems and stuff like that. B here is our base, what we consistently multiply by. Okay, x is our variable, and then c here, oftentimes what's important is for an exponential function, the line y equals c is our asymptote. Right, and so we'll talk a little bit more about what the asymptote is. All right. So here, the base, okay, which is b here, is a positive number that is not 1. Okay. The reason why it has to be a positive number is because if it's a negative number, depending on what x is, it'll move back and forth between positive and negative. And that's not what our exponential function does. Okay. So it has to be a positive number, and it can't be 1 because 1 to any power, right, is just 1, right? 1 times 1 is 1. 1 times 1 times 1 times 1 is still 1, right? So that's why our base cannot be 1, because it wouldn't change anything. Okay. The simplest cases have an a value, a starting amount of 1. Okay. So here we look at some examples. F of x equals 2 times 3 to the x. 2 here is our a. 3 here is our b. We don't have any c's. Right? F of x equals 4 to the x. Right here, our a is 1, and there's no use in saying 1 times anything, so that's why it's not there. Okay, and then 4 is our b. Right? And then here again, f of x equals 1/2 to the x power. Again here, a is 1. Right? Again, there's no reason in putting this 1 here because 1 times anything is itself. Okay? And 1/2 here is your b. So what an asymptote is, I just talked about how if you have something and then it's plus c here, for our exponential function, that the line y equals c is our asymptote. What an asymptote is it's a line that the graphed function approaches. It gets closer and closer and closer to it as our x gets either smaller or bigger. Okay? The way I remember it, asymptote sounds like the word ass. Ass is butt, right? Don't touch the butt, like in Finding Nemo, right? So the asymptote is something we get closer and closer and closer to, but we never touch it, right? Because we don't touch the butt, according to Finding Nemo. Okay. So here we're going to start by graphing it. We're going to graph two functions. One function here is going to be g of x equals to the x power. The other function here is going to be h of x equals 1/2 to the x power. Okay. All we're going to do is plug in these numbers to solve. And then we're going to find some of its key features like domain, range, x-intercept, y-intercept, asymptote, and then we're going to graph it here. Okay. So we're going to start, I'm going to start with g of x. Okay. So if x is -4, all I have to do is plug it in. So 2 to the -4th power. Okay, we know it's a fraction, so it's actually 1 over 2 to the 4th. Okay, so 2 times 2 is 4, times 2 is 8, times 2 again is 16, so 1 over 16. Okay. Then 2 to the -3rd power. Okay, again, negative exponent, so we know we need to flip it to the bottom. Okay, so 2 times 2 is 4, times 2 again is 8, so 2 to the -3 power is 1 over 8. Okay. And I'm going to keep going 2 to the -2nd power. Okay, we know, again, negative exponent, so it should be flipped to the bottom. Okay, 2 times 2, right, is 4, so 1/4. Then 2 to the -1st power, flip it, be 1/2. 2 to the 0 power, we know anything to the 0 power is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third, we know 2 times 2 is 4. Times 2 gives you 8. Okay, so 2 to the third is 8. Okay, 2 to the fourth. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So 2 to the fourth is 16. Okay. Now I'm going to graph these points. Okay, so x, and then g of x again means y, so these are my y values. So negative 4, comma 116. So negative 4, 116. Okay, negative 3, 1/8, and negative 3, 1/8. Okay, negative 2, 1/4, negative 2, 1/4. Okay, negative 1, 1/2, negative 1, 1/2. 0, comma 1, 0, comma 1. Okay, 1, comma 2, 1, comma 2. 2, comma 4, 2, comma 4, 3, comma 8, so 3, comma 8, and then 4, comma 16, so 4, comma 16. Then I'm going to connect the dots. Oops. Arrows at the end because we're going to keep going forever. Okay, so let's find some of its key features before we move on to graphing h of x. Okay, so my domain for g of x, right, as you can see, we go to the left forever, we go to the right forever. So my domain here is all real numbers. It's negative infinity to infinity. Okay, my range, okay, it gets closer and closer and closer here to y equals 0. Okay, but it never touches it, right? We saw that when we talked about decay, things getting closer and closer, but never fully reaching it. Okay, so that's the same thing here. We're going to get closer and closer and closer. This number, as we go towards x being negative, is going to get smaller and smaller, but it's never going to reach 0. Okay, so the range for g of x, it's close to 0, but doesn't quite touch it. And then it goes, as we see, as we go to the right, it goes up. X-intercept here, since it never touches this axis, there is none. Okay, there is no x-intercept. Y-intercept, here's the y-axis, touches it here at 0, comma 1. Okay, so y-intercept is the point 0, comma 1. And then the asymptote, like I said earlier, it gets closer and closer to this horizontal line of y equals 0, but never touches it. The asymptote here is y equals 0. And so g of x, this function shows exponential growth, since as you can see, as we move to the right, the graph grows larger and larger and larger pretty quickly. Okay. So let's try doing h of x now. Okay, so we're going to take these x values and plug it in. Okay, so 1/2 to the negative 4th power. Okay, so we know we're going to flip it. Okay, so 2 times 2 is 4, times 2 is 8, times 2 is 16, so it's going to be 16. Right. Then we're going to have 1/2 to the negative 3rd power. Okay, so it's going to flip it, so it's no longer going to be a fraction. Okay, 2 times 2 is 4, times 2 is 8, so 1/2 to the negative 3rd power is 8. Okay. Then we're going to have 1/2 to the negative 2nd power. Okay, so again, negative exponent, so it's going to flip. It's going to do the reciprocal. Okay, so it's no longer going to be a fraction like 1/2. Okay, it'll be a whole number. So 2 times 2, 4. Okay. Then we're going to do 1/2 to the negative 1st power. We know that flips. It becomes 2. Then we have 1/2 to the 0 power. We know anything to the 0 power is 1. Okay. 1/2 to the 1st power. Anything to the 1st power is itself. Okay. 1/2 to the 2nd power. So 1/2 times 1/2 will give me 1/4. Okay. 1/2 to the 3rd power. So 1/2 times 1/2 times 1/2 gives me 1/8. And then 1/2 to the 4th power is 1/2 times 1/2 times 1/2 times 1/2, which will give me 1/16. Okay. So let's now graph it. Okay, so here are my x values. Again, h of x here is just another way. It's our function notation way of saying y. Right, so we're going to start with negative 4 comma 16. So negative 4 comma 16. Negative 3 comma 8. Negative 2 comma 4. Negative 1 comma 2. 0 comma 1. 1 comma 1 half. 2 comma 1 fourth. 3 comma 1 eighth. And 4 comma 1 16th. So all I did was x values, y values. Okay, so now let me connect it. And then here it's going to get closer and closer and closer and closer and closer, but never actually touch it. Okay? So let's look at domain and range. Okay, that was at the end. So here, the domain for h of x, as you can see, it goes to the left forever, goes to the right forever, nothing is stopping it. So also, negative infinity to infinity, okay, it's also all real numbers. Okay. Range for h of x, as you can see, here as x gets bigger and bigger, it gets closer and closer to 0, but never touches it. So here, it's going to be 0 to infinity, or y is greater than 0. X-intercept, although it gets closer and closer to this line, it never actually touches it, so there is also no x-intercept. Y-intercept, here's the y-axis, touches it at 0, comma 1. So y-intercept here, h of x is 0, comma 1. Asymptote, the line it gets closer to but never touches, because it never touches the butt, right? Gets closer to this line. This line has an equation of y equals 0. Okay. And so, for the function h of x, okay, the function shows exponential decay. Since the graph decays, it gets smaller and smaller and smaller and smaller and smaller. Okay. So something here, just to remind you what an asymptote is. An asymptote is a line that a graph function approaches as the value of x gets very large or very small. Okay. So you can see that here it gets closer and closer to this line but never touches it. So let's try one more. We're going to graph f of x equals to the x minus 1. We're going to state the y-intercept, the asymptote, the domain, and the range. Okay. So here there's a table. Normally I would just do like negative 2, negative 1, 0, 1, and 2 instead of these numbers that aren't very consistent, right? Those are the numbers I would usually use. Negative 2, negative 1, 0, 1, and 2. Okay. So let's plug in. Okay, so 2 to the third minus 1. 2 to the third. 2 times 2 is 4, times 2 is 8, so 8 minus 1. That gives me 7. So my y value is 7. Okay, then the next one, 2 to the second minus 1. 2 to the second is 4. 4 minus 1 is 3. Okay. Then 2 to the 0. All I'm doing is taking these x values and replacing x with that number. Okay, so 2 to the 0 minus 1. We know anything to the 0 power is 1, so 1 minus 1 is 0 here. Okay. Then 2 to the negative second power minus 1. Okay, we know 2 to the negative second power is 1 over 2 square minus 1. 1 over 2 square we know is 1/4. 1/4 minus 1 is negative 3/4. And then 2 to the negative fourth power minus 1. Okay, that negative exponent tells us to reciprocate, flip it. Okay, minus 1. Okay, so this becomes 2 to the fourth. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So this should be 1 over 16 minus 1, and this gives me a negative 15 over 16. Okay, so let's graph it. So I'm going to start with 3, comma 7. So 3, comma 7. Okay, 2 is 2, comma 3. Then it's 0, comma 0. If you plugged in 1 and 2 to first, it'd actually be 1 here. Okay. Then here it's negative 3/4. And then negative 15/16. Okay. So then I'm going to connect. Arrows at the end. Okay, so y-intercept, where does it cross the y-axis? Crosses it right here at 0, 0. This is also the x-intercept because this is also where it touches the x-axis. Okay. Our domain, as we can see, it goes left and right forever with nothing stopping it. So negative infinity to infinity, also known as all real numbers. The asymptote here, okay, I told you when it has a c at the end, this here is the asymptote. So the asymptote is y equals -1. As you get further and further in math, we not only have horizontal asymptotes, we also have vertical asymptotes, right? So what this means is it's going to get closer and closer to this line of -1, but never actually touch it. Okay, because we're humans and we can't make it super, super close, that's why you can't see it. But if you looked at Desmos and you had him graph this, you can keep zooming in closer and closer and closer and closer, and you'll see it gets closer and closer to -1, but it never actually touches it, it never reaches it. Okay, so my range, everything is above -1, so my range here is -1, comma, infinity. If you wanted to write this in inequality notation, it'll be y is greater than -1, right? Not equal to, because it never actually equals it, it never actually touches it. Okay, so that's it on graphing. I hope it helps. Really, we just make a table, note its features, especially the important one is that asymptote that it gets closer to but never touches, right? And then we just plot our points. So that's it for today. Have a great rest of the day. Bye, guys.